Okay, for this part of the review, we are going to be solving systems. And we talked about two algebraic ways to be able to solve systems. One which is substitution and one which is elimination. We also talked about graphing as well. If we look at this problem can be done either way using substitution or elimination. The first way I'll show you is by using elimination. This is actually lined up very well to do elimination because if you look at our lines, our columns here, you could see that with our y variables, we have opposites. And so if we take and draw a line and add these two equations together, we'll have 1x plus 2x is 3x. Positive and negative y will cancel out, thereby eliminating the y variable. 3 plus 3 will give me 6, leaving me with a one-step equation to solve, and I now know that x is 2. And then I go back up into either one of the original equations. I'm going to use that x plus y equals 3. I'm going to put in place of x, I'm going to put in a 2. And I can solve this to see that y is equal 1. So there's my x and my y. The ordered pair is 2, 1. The other way that I could do this is using substitution. And since both of these equations are easily solved for y, the most common way we see this is if we would take this first equation and solve it for y, it would be y equals negative x plus 3. If we take the second equation and solve it for y, we would have to take the 2x over to the other side and then divide everything by negative 1. And now we have two equations that are in y equals form, or slope-intercept form. And so therefore we can set these two equations equal to each other. So I could take the 2x minus 3 equal to the negative x plus 3. And now I can solve this. I would add x to both sides. And then I'm going to add, I see subtract 3, I'm going to add 3. I'll end up with 3x equals 6, and x will equal 2, which is exactly what we found when we did elimination. We could then continue, do the exact same thing. I would do this exact same thing of taking one of the equations. I'll happen to just show you the second one this time just to show you that it works. And in place of x, I'm going to put 2. And then you could see that y is going to end up to equal 1. And our ordered pair would be 2, 1, which you can see that is the exact same thing that we got when we did elimination. All right, in our second problem, I'm going to focus on elimination. And what do we do if we do not have opposites? Well, we have to create opposites. So if we look at this, we could see if this is a 6x, I'm going to leave this as a 6x. But I want to be able to turn this into a negative 6x. So I'm going to take and multiply by a negative 2. That would turn that into a negative 6x. I have to multiply everything by negative 2 though. That'll turn this into a negative 2y and this into a negative 8. And so now I'm going to take and add these together. If I've done this correctly, I will eliminate the x variable because that's what I tried to eliminate by creating constants. But something happens in this problem where I also eliminate the y variable. As soon as that happens, I now know that of my 3 types of problems where I have a one solution, a no solution, or infinitely many solution, I now know it cannot be one solution because both my x and my y canceled out. It's going to be one of these 2 choices, and how I decide that is by looking at the constants. I have a -8 plus a -8, which is going to give me a -16. That does not equal each other, and therefore there is no solution. That means that these lines are parallel to one another and never cross over each other. Now, if we pretend that these constants here canceled out and ended up with 0 equals 0, that would make it infinitely many solutions because it would mean that it's the exact same line. Same slope, same y-intercept, that means infinitely many points that are solutions.